Dear respected all, I'm Paulus Makana, originally from Ethiopia. Now I'm attending my master's here in Humanisper in the University of Section Olunsa in the program of MTech in the Mass Computer Science and Engineering. I'm going to present the topic of new approach modification Grasshopper optimization algorithm in machine learning and application. This is what we have done with my co-authors, with Archana Sarangi, Shubhendu Kumar Sarangi, and me, Paulus Makana. The content of the slide I'm going to present is, first, there is introduction. Under the introduction, we are going to see about the swarm intelligence algorithms, also about the optimization algorithm, about the nature-inspired optimization algorithms. On the second, the approach of Grasshopper optimization algorithm. We can name that GOA. This is how the original or the classical optimization algorithm, how it works. On the second, the challenges or the limitations found in the Grasshopper optimization algorithm. We'll see. The third, the modified Grasshopper optimization algorithm. This is the algorithm which we are modified and what techniques and methods we are added on the standard modified standard algorithm. On the fourth, the result analysis of the new algorithm, how to simulate from what's the difference between the original one or the standard one and the modified one. In the last, there is a conclusion. After that, the reference. Here, swarm intelligence is a field deals with understanding and simulating collective behaviors of organisms without a central control unit in the nature. This is a collection of behaviors, of the organisms or swarms are in without a central control unit. How they the movement of they make the movement in the given or in the bounded region, how they can perform at random positions. Swarm intelligence is a field of populations made up of a simple agent interact with each other in a given environment. This also shows that this is a population based that are interact in a given environment or in a bounded environment. These agents interact locally, often also incorporate random mechanisms to achieve goal of globally. These agents or populations are interact locally and globally to achieve the goal or a solution of the problem. Swarm intelligence algorithm also based on the nature-inspired algorithm. This is a field that arises from the nature-based algorithm. Nature-based optimization algorithms are the set of problem-searching methodologies to find a solution by the approach derived from natural process. This natural, as the name is, from the name we can understand it's a nature-inspired optimization algorithm. This is the situation how it's based on natural flow. So optimization algorithms used to solve optimization problems, find the best solution from the large set of possible solutions. These optimization algorithms are type of algorithms are certain methodologies that are based in nature process to find a best solution from the large possible of solutions. When we come to the approach or the standard Grasshopper optimization algorithm or the GOA, as it's named in GOA, GOA was the first proposed by Sarem in 2017, before 3 years back. This is the algorithm is based upon the population-based algorithm. It is a gradient-free algorithm. This gradient-free algorithm means it is free from derivative. And also it's a nature-inspired stochastic optimization algorithms. Is nature, and another also is stochastic. The movement of these agents are they move randomly in the given environment. The algorithm also develop a number of historical information that have a number of available solutions. Then when the algorithm is calculated, the mathematical calculation of the algorithm based, it's produce a number of historical information that can be a possible solution. Here, how the algorithm is calculated, or these agents are interact by this formula. Xi is the position of the grasshopper algorithm. C is the decreasing coefficient. N is the number of grasshoppers. There is upper bound, lower bound, dimension, and the target value of TD, or target value function. Here there is C coefficient value. This coefficient value is decrease proportional to decrease or to balance exploration and exploitation. Here exploration is the capability to consider various areas in order to get hopefully the global value. Exploitation is the capacity to concentrate specified region or location precisely. So this C value is decreased proportionally to balance these two, exploitation and exploration. The challenges found in GA or standard GA algorithm is, one is the key problem found in GA algorithm is to adjust the balance between exploration and exploitation based on C coefficient value. This problem is what many researchers or many papers suggest is the imbalance between exploration and the exploitation. There are also another challenge or limitation is it suffers from slow convergence. Another also it's getting trapped to the local optimum. And the new proposed method where enhanced or increase this outcome of exploitation and exploration. You can see how this algorithm of the new method is techniques prove this problem in case of exploitation and exploration. We'll see in the next slide. Here, when we come to the new modified optimization algorithm, and then the name is as MGOA. This new modified optimization algorithm utilized or used both method of binary crossover and the polynomial mutation, consequently to increase exploitation and exploration of the search process or in the search space. The crossover is used to make swapping agents randomly in cross sites as well as enhance a wider diversity in the search pattern. As we know, crossover techniques is used making new offspring from their parent, so it's swapping those agents. This is helps to make a wider diversity in the search pattern. Another technique is was utilized in this algorithm is polynomial mutation. This also utilized create high distributive mutation, and by the help of these two techniques, the algorithm perform a super performance more than that of standard algorithm of GOA. These techniques provide the ability to escaping from the local optima. Here, when we come to here, this is the pseudocode of the new modified GOA algorithm. The new modified, or that means is the new modified of the GOA algorithm. On the first line, first there is initialization of parameters like C mean, C maximum, C minimum, also maximum number of iteration. After that, there is initialization of the algorithm or agents, and directly here there is after the initialization or after the random initialization of the population, directly the algorithm takes to binary crossover and polynomial mutation. After that, there is a calculation of the fitness. Next to there is a selection of the target best solution from this fitness of agent, and after that the algorithm is, works. It is through iterated by the loop, and it enters to in the loop and updates the C value. When there is another loop inside, it's a for loop. In the for loop, it normalizes the distance between two grasshoppers, and updates next to that, it updates the current of search agents by equation of the in the previous formula. It calculates the agent's position, and if the agent goes outside of the boundary, here on the third line, it comes to in the boundaries, makes it into found in the boundaries, and this is for loops iterate until the end, and after it's finished, it updates the t or better value of the solution. This for loop is iterate with the l plus 1. When the while loop is end, it comes outside of the while loop and returns the target fitness value. The proposed technique is tested on standard benchmark function on both unimodal and multimodal functions. The simulation process is clearly shows that when it's compared to the standard or the classical GOA, the new modified GOA algorithm enhanced over GOA. You will see how that is the result in terms of mean value, in the average value, and the precision value, as well as in the convergence next. Also, standard parameters are utilized for such as, for example, dimension 30, iteration 500, and they also fixed constant probability for crossover 0.2 and the for mutation is 0.8. Like okay, here on the result analysis, according to the table below, the repeated experiment taken modified GOA exhibiting most desirable value in terms of the precision range values. Here in this table, there are two tables. One is for standard Grasshopper optimization algorithm. The second one is the modified Grasshopper optimization algorithm. On the first table here, on the standard GOA optimization algorithm, here is the value of in best, in worst, and a mean value. For example, if we take it, the first function of A and W are a unimodal function type, and the third and the fourth are a multimodal function of type, multimodal function of benchmark standard functions. Here, if we see the loop, if we look the difference, for example, if we compare it, the first on the first standard Grasshopper optimization algorithm, the value of investment is 1.6018, and the worst one is 1.6214, and the mean value is here. And when you compare came to in the modified GOA algorithm, on the same function on modified Grasshopper optimization algorithm, we got it 0.22982 in the best case. In the worst case, it's 0.22988, and the mean value is here 0.22986. The same to that when you come to function function B, this one of unimodal function, standard benchmark function. The same to that in the best mean value, in the worst case, in the mean value. When you compare to here and the came here, say for example, the best mean is 0.01262, and here it's 0.00025. It's almost nearly nearest to zero. The same to that, the worst case value and the mean value are there is big difference, and when the mean is here, it's 0.01268, but here it's 0.0002568. And on this and the function C and D are the type of multimodal functions. On this, the best mean value is 1.6456. Here on the multimodal function on the below table, on the function C, on the column 2.08 times 10 to the power of -5. There is a big difference. The modified GOA algorithm is more than perform more than that of the standard one. Here the same to that, if you see the last function D, standard benchmark function, here the best mean is 0. Here in standard function the result is 0.01982, but here in the modified function the algorithm is performed, the result is 8.78 times 10 to the power of minus 8. According to that, the worst is 0.01136, and here the worst case is here, it's 8.99 times 10 to the power minus 8, and there's a big difference. The same to that, the mean value is 0.01988, but here is 8.8 times 10 to the power of minus 8. So when we conclude from this, a MGA algorithm clearly shows that on both unimodal and multimodal function, it's a superior perform more than that of Grasshopper optimization. Here in these 4 simulated figures, the first 2 graphs are the unimodal benchmark function, the second are type of multimodal benchmark functions. When see here in the F2 square field function, the red line is for a modified Grasshopper optimization function, the black one is for the Grasshopper optimization algorithm. If we see the superiority after the iteration of 100 iteration, there is, if you compare it, there is a great separation result between the 2 algorithms. Also same to us on the second figure on F7 recurrence function. After 200 iteration, the modified Grasshopper optimization is have a superiority more than that of the Grasshopper optimization of the classical one. The same to that on the both multimodal function of F10 and F30. At the field, both algorithms are competing each other, but after 400 iteration, the modified optimization algorithm have a superiority more than that of Grasshopper optimization of volumes of the classical one. Here, what you conclude from this graph, convergence simulation graph, the modified Grasshopper algorithm can reduce cost good in a good minor way, have superiority result than that of old Grasshopper optimization algorithm. When we come to the conclusion, the newly modified Grasshopper optimization techniques utilize 2 methods. One is binary Grasshopper optimization along as with the polynomial mutation for enhancement of the quality outcome with increased exploration as well as exploitation of available solution. The simulation is done using standard unimodal and multimodal function for providing superiority results. The proposed testing domain simulation provide superiority along with effective algorithm compared to classical GOA. Therefore, the suggested version of algorithm is suitable for handling complex engineering and scientific variety real-world application. As we seen from the result of the simulation of the convergence graph, the algorithm have the ability to reduce the cost value than that of the classical optimization algorithm. So the modified algorithm optimization algorithms have superiority more than that of the standard or Grasshopper optimization algorithm. Here there are around 5 references that I used it. The first one is a paper of multi-objective optimization using evolutionary algorithm. This is with Deva and Kalhanomi. The second one is Sarah with Sarin and Aid Ali Marjalil. This is title of Grasshopper optimization algorithm and the theory and application. On the third, there is also simulated binary crossover and the continuous search space. These techniques of about binary crossover and implementation found on this book. Also on the fourth, there are Deva Kalhanomi also analysis of mutation in the four-leaf parameter genetic algorithm. And the fifth one paper is the probability definition evolutionary criteria. In the 2005 benchmark function is here found in Chungaton. Thank you so much.